All right. Well, welcome everyone to chapter 10. This is going to be acids and bases, our first few videos in this chapter. Exam 4 will cover all of chapter 10 and a portion of chapter 12. So way less content. Usually we do 3 whole chapters, but we're just going to mainly focus on chapter 10, acids and bases. So if you have your textbook, if you've downloaded the lecture slides, follow along with me. I am excited to show you guys a new picture of a hike that is a really great hike. It's called Hemmed-In Hollow, and it's in the Buffalo National River Wilderness. If you are floating the Buffalo from Steel Creek to Kyle's Landing, those are 2 put in, get out points of the river, then you will actually pass a part of the river where you can park your canoe or your kayak and hike to Hemmed-In Hollow from the river. It's a really flat hike if you do that, or you can drive to a little place called Compton. There's a trailhead from Compton. You can park there, some gravel parking area, and you can hike down to Hemmed-In Hollow from Compton. I'll warn you though, if you park at the Compton trailhead, then the hike to the waterfall is all down, but when you go to hike back to your vehicle, it's all up, and it's a really steep hike, but it's still a great hike. You can see the waterfall in this first picture. This is when it's really full in a rainy season. If you go in a dry season, you'll be lucky if you see a trickle of water at all. But it's a really great hike. It's in, again, the Buffalo River area. If you drive up to Ponca or the Buffalo Outdoor Center, they can easily direct you how to get here. The next picture I'm going to show you though is a different trail. It is called the Lost Valley Trail. One of my favorite trails in the Ponca Buffalo River area, and the reason why it's one of my favorite trails is because it has this cave. As you can see, this is a picture from the inside of the cave looking out. But it has this cave towards the end of the trail, or at the end of the trail, and if you hike far enough back in this cave, I'll warn you though, it gets pretty tight. Small spaces. At one point you kind of have to get on your hands and knees and crawl a little bit. So if you're claustrophobic, don't recommend it. If you don't like small, tight, dark spaces, don't recommend it. You need a headlamp when you get to this point, because you'll go far enough back in the cave that you'll need some light. But if you go back far enough, there is actually a waterfall within the cave. So again, you're going to want a cell phone light, flashlight source. A headlamp is what I recommend so that your hands are free. But the reward of this trail is you hike back into the cave and you see a waterfall. It's a pretty good waterfall too, inside the cave. So anyways, that is called the Lost Valley Trail. Not a very crazy long or difficult hike, but these are 2 really great hikes here in Arkansas that I wanted to show you guys about, or at least tell you about before the semester was over. But all right, moving on. I don't know about you guys, every time I cough or sneeze now, I'm like, do I have the virus? Hopefully not. It is pollen season, so be careful outside anywhere. All right, acids and bases. So we're going to introduce acids. I'm just going to kind of open up this question. It's weird asking a question on a video. It's different than if I would have asked it in person in class. I miss having class with you guys, by the way. But what do you think of when you hear the word acid? Okay, obviously, probably don't think about this one, psychedelic acids. That's not what we're talking about in this class. Maybe you think about citric acids. If you're anything like my husband, he loves sour, sweet candy. He would rather have Skittles or Jolly Ranchers. But maybe you think of acidic foods, okay? And the sour taste that comes from things like citric acid. Maybe you think of corrosive substances, because acids are corrosive. They can, at a high enough concentration, be very dangerous to our skin. And so, I don't know, maybe you think of stomach acid. Acids are useful in our body. They help us break down and digest our food. There's all different kinds of things we can think of. But the way we're going to define it for the purposes of this chapter and exam 4 is an acid is a chemical that donates what we're calling a hydrogen ion to another chemical or molecule. Okay, so I want to talk about a hydrogen ion for just a second. We are familiar with ions, cations and anions. A hydrogen ion, you can see, is a cation. It has a plus charge. Hydrogen, if we look at the periodic table, hydrogen has 1 proton and it has 1 electron starting out, okay? That's a neutral hydrogen atom. But when it becomes an ion, like what we see here, that means it has gotten rid of its electron, okay? It's donated its valence electron, given it away, so essentially we could erase that. And all that's left is a proton, 1 proton in the nucleus. There are no neutrons, it's just 1 proton. So if you look at this statement over here, we sometimes call a hydrogen ion a proton because that's all it is. You'll hear me use that word interchangeably. You'll say I'll say the acid donated a proton or the base received a proton. And when I say that, what I'm talking about is a hydrogen ion. But I know myself, I use these terms, hydrogen ion and proton, interchangeably. So get comfortable with that. Don't be confused by that. Because a hydrogen ion is a proton. And then because of what we just talked about, we nickname acids proton donors, okay? So just because when they're donating a hydrogen ion to something, like we said, they're donating a proton. So they're nicknamed proton donors. All right, so that's how we're going to define an acid. Moving on, we're going to just look at an example reaction of an acid with water, okay? One of the main goals for this chapter is for you to be able to look at a chemical reaction and identify on the reactant side what is your acid, what is your base. And then by the end of, in a few videos, I don't know if we'll get to it in this particular video, but we're also going to talk about conjugate acids and conjugate bases. Those are the products that result from an acid-base reaction. So identifying those things. So we're just going to look at an example reaction here. We have hydrochloric acid, HCl, and we have water. And so what happens when we have an acid in aqueous solution, okay? If it's in solution, aqueous solution, that means it's present with water, okay? And what happens in that case, how do acids naturally behave? Well, like we said, they're going to donate the protons. So here is the acid, hydrochloric acid. Here's the proton or the hydrogen ion that's going to be donated, and it's going to be donated to the only other thing present, which is water. So this hydrogen is going to leave HCl and it's going to go over to water, and when that transfer is made, what's left is Cl minus. That's one thing, but then we create this right here. We have that the water molecule actually receives that hydrogen that was donated from hydrochloric acid, and it makes this unique thing that we call a hydronium ion, a water molecule with an added hydrogen ion. And overall, now that water molecule, usually water is a neutral molecule, right? It has no charge, it's neutral. But on the product side, now we have this plus charge because we've added a hydrogen ion, which carries a plus charge, okay? So we call this, again, we call that a hydronium ion. So you need to know the name of this. But then too, just the way sometimes I say hydrogen ion or proton, H3O plus and H plus are used interchangeably. Why? Because this hydrogen that we've added to our water molecule, it can come on and off of water. Okay, so the hydrogen ion can come on and off of water molecules. There's really not a crazy strong affinity to water molecules. Hydrogen ions are very reactive, so they do bind to water molecules, but they can come on and off. So that is why we use H3O plus and H plus terms interchangeably, okay? They essentially mean the same thing. That might sound weird, feel